All right, everybody. Today we have Michael from Rentfuse. Michael is a software engineer with a background of 5+ years of building widely used software spanning from mobile and web applications to HMI for smart robots. He's been fascinated about the incredible use cases of the blockchain technology since reading the book Blockchain Revolution by Don Tapscott. Now he's leading Rentfuse Labs, a team of makers that is building Rentfuse, the first NFT renting protocol on the Neo blockchain. And he also was a winner in last year's hackathon held by Neo Global Development. So, Michael, can you tell us just a little bit about Rentfuse?
Yeah, Robert. At first, I would like to thank you, everybody, for being here. It's really good to have an opportunity to talk to other coders or person interested in development on Neo. So, at first, who I am, as Robert told you, I'm a software engineer. I'm the founder of Rentfuse. Rentfuse is an NFT renting protocol. We are part of the early adoption program, and we are building the sharing economy on Neo. With Rentfuse, you can use your NFTs to lend them and to earn some revenues, or you can rent them and use them temporarily. In order to do so, the cool thing is that you have two ways of doing that. You can use the normal collateralized mode, that is a mode in which you can rent your NFT, any kind of NFT, with a simple escrow, when you as the lender lend your NFT by listing it, and the borrower deposits a collateral and borrows the NFT for the amount of time. The other mode is a NFT safe mode, because is called the proxy mode, and is a way to rent NFT in which we use some kind of placeholders. Okay, let's keep it in this way. You use some kind of placeholders that represent your rented NFT. In this way, the lender NFT stays in the rent protocol's vault and is never transferred anymore. Only the placeholders go around. So these are basically the two ways the Rentfuse protocol is working.
Fantastic, Michael. And today you're going to show us Neon Wallet Adapter. Is that true? And also some other aspects?
Yes. So give me 1 second. I'll start to share my screen. Can you see my screen?
Yes, I can. It says Rentfuse DevLog 17/1.
Yeah. Okay, so the idea of today is to go through two tools that we made, that are NeoNova and the Neo Wallet Adapter, with a top-down approach. So we'll start from seeing the upper level, so NeoNova, the web application, and so on, and then we dig deeper to the code level and seeing the implementation. But what are NeoNova and what is Neo Wallet Adapter, why we made them? So at the beginning, while we started developing on the Neo blockchain, and generally when we develop a front-end application that needs to communicate with the blockchain, you need to support a lot of wallets, because there can be different wallets builders, and you want to provide your users all the wallets available. So you want to accommodate your user and give them the possibility to use the wallet they prefer. For doing so, at the beginning, due to the fact that on Neo we had 3 wallets when we started at the beginning, so Neoline, O3, and Wallet Connect, we thought about creating a library that could easily abstract the usage of this wallet in a way that we could simply use only the same methods to interface with the wallet. So what we thought was, well, we are building something that could benefit other users, other developers, could really help them avoid the that you can have at the beginning, creating interaction of the wallet. So we saw the opportunity to create this package open source and be used by other developers. And this is the new wallet adapter, and we go through it. But while doing so, we also talked about when you need to test and when you need to do some invocations on your contracts. We are used to use Postman. Is a free advertisement for them, but Postman is a really good tool that I think that any developers know it. Is a way to interact and doing REST API calls, but many other things with plugins. And so what we thought was, well, it would be awesome if we could create something to easily interact with the Neo blockchain. At the beginning, we had some script to do some maybe invocations or some deploy update on the testnet. So we said, okay, let's do a little bit the extra mile, create something that also other people can reuse. So our idea is always the fact that if we share something and if we build something together, we can move faster, because this is the power of open source. So tools that can be used by many people, it would be at least wonderful if we can share them and improve them together. They will be more resilient and also more, let's say, with less errors or bugs. Okay, so for today, as I told you, we'll start from the NeoNova. This is basically what we already saw. So we go through NeoNova. Okay, so what is NeoNova? NeoNova is a web application to make invocations on the Neo blockchain. Let's add directly to the NeoNova website. Okay, I directly prepared it here. We have the website that is hosted on neonova.space. So we start from seeing the UI, how it's organized, how you can use NeoNova, and then we'll move on to the code level of it and the new wallet implementation. So how is composed the UI? The UI is composed by, on the left, a navigation bar with the different pages you can navigate through. In this case, we have only two pages. The first one is the one related to the invocations, and then you have the other ones related to the contract interaction. This is also, let's say, empty to give to allow the addition of more functions in the future. At the end, it's an open source tool. If there is something we find that is useful, we can directly integrate it. So, and then we have on the top bar, we have information about the page in which we are, and we have two important buttons that are the one related to the connection with the network and the wallet. Let's start with the first page, that is the contract, the invocation page. Okay, this page is the one that allows you to interact with your contracts on the blockchain. So at first, you need to set up the network on which you want to be connected. You have to just click the button on which the network is selected, and you can select it. So you can choose between the mainnet or the testnet. There are also many RPC addresses available. As you can see here, some are HTTPS provided by City of Zion, for example, these two, and then there are HTTP ones. And due to the fact that we are hosting the NeoNova website on a HTTPS domain, we need to use the HTTPS RPC addresses for the course policy. But we have added also the normal HTTP one, because if you clone the project, it's open source. So if you clone the project from GitHub and you run it on your PC, you can directly use the HTTP one if you prefer. So we have our RPC address here. So we are connected to the testnet. And then we have this button that allows us to select the wallet we want to connect. For this demo, we will use Neoline. So we connect with Neoline. Okay, so we selected Neoline. Now this button changes and it says that we'll be connected to Neoline. We click on it and we are directly connected. This is because I already set up Neoline to be directly connected to allow directly NeoNova to be connected. So as you can see, it's a matter of seconds. If you if it's the first time you click on that, it will prompt Neoline to accept the connection with the website. So let's go straight to the invocations. There are two kinds of invocation. Each of these tabs represents an invocation. You can add you can add whatever you want. But let's see the invocation tab and how it's organized. You can see here that you have two types of invocation. We have the read invocation and the write invocation. A read invocation is an invocation that is done through the test invoke. It's directly handled through the fantastic library made by City of Zion, that is Neon.js. And is an invocation that doesn't need any wallet connected. And there is no gas paid for the transaction. So it basically doesn't need to have the wallet set. It's an invocation that gives you the results and allows you to read from the Neo blockchain. In this case, the structure of the invocation will ask us to insert some data. At first, we insert the script hash as an X string of our contract. Then we insert the name of the method we want to call, in this case settings, and then we can add an amount we want of arguments. We just click on the plus and we have a new argument that is added here. Each argument is passed to the invocation in the order you see they are added here. So if settings is a method that accepts one argument, you have to add it and add the arguments here. For the arguments, you can select different types of them. You have all of them here. So this is because we cannot infer the data you want to transfer, because maybe your methods need to have some data passed in a particular way. So what we thought is that you decide the type of your invocation to be really clear on what you are calling, what you are invoking, and you insert the value. This value in this case is a string, but you can insert anything that is related to these types. So Boolean, integers, and so on. If you want to delete an argument, you just click this button. So this is how you compile, let's say, how you fill an invocation. Now we set up everything here, and then we want to see the result. But where we see the result of a read invocation? You will see them here on the right. On the right, you can see that this is a JSON viewer that will represent the data, the result we are receiving from the blockchain. So what we do is that we click on the send method to send the invocation, and we'll have here directly filled the whole content of the result. So you have all the information of your call, of your read call. In this case, I'm returning a map of values. These are the settings of one of Rentfuse contracts. So the interesting part of this result tab is that at the beginning, while we were developing, where we're doing some invocation, some read invocation, we received some raw data, and each time we had to the code some values. In this case, due to the fact that we wanted to give the possibility through this tool to automatically decode the data, what we told was, well, we cannot infer on the type of the byte string you may are requesting, okay? But we can give a way to decode them dynamically when you have the result. Because that is the problem. Because if we know that the result is a number, an integer, or whatever, we cannot directly decode it and show you the number. But if we don't know the type, and the type is, for example, a byte string, you just have an encoded base 64 byte string. So you don't know what you will have written here. You just have the X string that represents the data. So in order to make it more readable, we thought that if you click on the key, on the byte string, on the X string value, on the base 64 value, it automatically tries to decode it as first as string, then as number, then as address, and then back to the original X string. This, as I told you, is as you can see here, is to directly see the result, to decode it on the fly. So in this case, as you can see, I've just decoded it on the fly. I can see that it resulting with this, and so okay, that's good. Maybe I did it correctly or I did it wrong. And okay, and these were the read invocations. Let's move to the write invocation. So here is all the same. So all the compiling is the same unless the read and write setup here. I have to make a precision here, is that what we added for the sake of simplicity at the beginning is that when you do an invocation, a write invocation, we are calling with the scope global, with the witness scope global. That's not a good thing, obviously. We did that because with the global scope, we are sure the invocation will go through. But in the future, we'll add another control here, or maybe you will add some other control here that let the user select the kind of a witness scope, so that we have more flexibility on that. So we added all the data. We set the write invocation. Our wallet is connected, otherwise it will give us an error, and then we send the invocation. Now we are sending to the same contract we have here to update the paused storage, to set it as paused. So we send the invocation. Now we have we have neoline that show us the invocation. We press yes, and the transaction is submit. Now the transaction is submit. So we send the invocation through neoline, and the data is updated on the blockchain. So we saw here it was already true, but we had updated the data on the blockchain. This is covering the read and write operations. So the invocation you can do on your contracts. You can do them on the testnet, on the mainnet, depending on your need. It could be useful. In our case, we were thinking about, for example, in this case, updating the status of the contract, and it was easy to be done through this in this way. Then let's move to the contract page. This is really similar, but is mainly used to do some operation on the contract. Basically, two operations. The first one is the deploy. Sorry, can you mute the? Okay, thank you. Okay, and as first there is the deploy method, and that is to deploy a new contract. So in order to deploy a contract, we need to import the compile file, so the NEF file and the manifest file. by going through these two imports, we are importing the data of these files, and by clicking on deploy, we are deploying our contract on the selected network with the selecting account. Then, if we have set an update method on our contract, we can add its script hash, add the new contract NEF file, the new manifest, and we can directly do an update call to update the contract. So this covers the how NeoNova can be used. Is made to follow the KISS principle and to create something easy to be used and really straightforward. Obviously, there is a lot of room for improvement, and it would be awesome to do it together. In fact, the NeoNova repository is on GitHub. There is anything here. Is free to clone it, to fork it, to add a new implementation, to make pull requests. We usually add maybe some issues that are like in this case, some possible enhancement or call to action on how we plan maybe in the future to add some new functionality. You can grab them and integrate them if you want, or you can add them. Maybe you have some idea, you can create a new issue that could be an interesting enhancement. We can speak about that and work together to implement it. Now, we spoke about NeoNova, but how NeoNova interact with your account? It interact with your wallet, your account in the wallet, through the Neo Wallet Adapter library. The Neo Wallet Adapter library is a modular TypeScript wallet adapters library that has some TypeScript components, TypeScript classes, TypeScript scripts, and some UI components that has the purpose of making it easier to develop a front-end application. This is the main goal. Also, the goal is to be flexible enough to not be completely integrated with the UI framework like the React, for example, but being framework agnostic, library agnostic, in a way so that at the moment we have integrated, we have implemented, we have creating a package with React, and because we are using React mainly, and so we are using with React. But if some of you know and prefer to integrate it with another library / framework, I don't know, like Angular, Vue, jQuery, whatever you prefer, okay, it is flexible enough to allow that and to create a new package for that purpose. So for NeoNova, we go directly with we go directly through code to see how it's structured, because the goal here will be to see how NeoNova is structured in order to know how can we maybe implement it together and to know how it works under the hood, to know how it can be improved and how things can be added. And then at the end, we'll see how NeoNova is implemented at the code level inside, how Neo Wallet Adapter is implemented at the code level inside the NeoNova. So this is the repo of Neo Wallet Adapter. You can see here that is a Learn application with many packages inside, all inside this packages folder. There are 4 main packages. 3 of them, the core, UI, and wallets one, are the ones that are published through NPM and are the one you can get through NPM and integrate in your project. So the first thing I would go on is the core packages. As you can see here, we have 3 packages: the base one, the React, and the wallet one. The base package is the one in which we have the core definition of what is an adapter. An adapter is an abstract class that defines a common way to interact with a wallet. We thought that if we define an abstract class and that our adapter needs to implement in order to communicate with the wallet, we could have a single entry point, so single methods to be used to interact with the wallet. So what we did is to create a lot of types, enum, and so on. So we described this abstract class that each wallet adapter we want to integrate needs to integrate this to extend this class. Then in the core package, there are some useful scripts, some useful functions, like we have a definition of some errors, polling functions, and wait transaction methods. So we have some utilities function that can be used if you integrate the package. This is and needs to be always present in each package. As you can see here, this is not related as it has any kind of relation with the front-end framework or library you want to add it. It's just a TypeScript code. The same goes for the wallets. The wallets are just a definition of functions that return a wallet object. So they take a configuration and they create a wallet object. In fact, as you can see here, they have some data that is useful mainly for a UI perspective and to keep reference of them. And then we have the creation on each function, the creation of the adapter that is representing the wallet you want to use. At the end, we have another core package that is the React one. The React one is a package in which there are a lot of useful components that can be used in React application to avoid giving you the effort of implementing them, but it gives you a direct and straightforward way to do, for example, invocation, to see some data, to react to some events and so on. In this case, we did that only for the React library because we are using React, but this is a package that could be extended. So we just can create another package. You can just create another package, Angular, Vue, and so on, here in the core folder that with the implementation you want to have in the Angular or the other library framework you prefer. Another important part is related to the wallets, is where the wallet adapter are described. So we said before that we wanted to create an abstract class that each wallet needs to implement in order to have a unique and a single point of entry to call wallet or wallet functions. Here is where the wallet adapter, this class is implemented. In fact, here we have that each of these package export a class that can be used to create an adapter. And obviously it needs to implement the base wallet adapter class because we need to have, as I said before, the same interface for doing the calls. So in this package, you'll see all the inner implementation that is, let's say, is implemented here and is removed from your efforts to implement the wallet connection yourself. So it's already done here. The same is done for O3 and wallet. Then we have the latest package that is deployed to NPM, the UI package. That package is it has inside some useful packages that allows you to move faster on some particular library with some particular components library framework. In this case, we have nDesign because we are using that, and React UI. What you can add many more you prefer. Maybe you use Material UI, so you can create another one here, for example. And these just cover and give you some useful components already created for you with the component library. So it is always to move faster. So these are the three main packages, and they are the packages that are deployed on NPM. But what if you want to create a new project? What if you want to start using New Wallet Adapter? What I suggest you, and what I did for NeoNova, for example, is to go on the starter page. You have two different starters already set up for you, and that can be built and are startable. And one is a Next.js starter, so blank Next.js project with inside you have already the packages that you need to make it work with the New Wallet Adapter, and all you need to make it startable. So all already set up for you. And this is to set up a blank Next.js application. Otherwise, if you prefer with nDesign, due to the fact that there are little tweaking to be done on the configuration level, you can use directly this starter. For NeoNova, we use this starter. And this covers let's say the code part of the New Wallet Adapter library, and everything is related to how New Wallet Adapter is all published on GitHub, as I said before. Also this one. You have here that, as we did before, we have some issue we added that could be maybe done with you, and some pull requests of some fantastic users that are doing some pull requests and are improving and that we are really glad there are these pull requests. By seeing on the page, you can see on the README that you have a quick way to kind of a documentation to set up the project with the React mainly because we are using it. And this covers everything we said before and everything we will see now on NeoNova. So you add all the packages. Then, always referring to React, we have a component that wraps everything on which we decide which wallet we want available. In this case, we want to have all of them available. So we use the function we saw before, and we create an array of objects that the adapter we want to use. In this case, we have new line O3 and the wallet adapter. Here you can see that the wallet connect adapter needs some configuration, and in fact, we can pass an object with some configuration. Here you can see that we have how the connection is handled. So we have a provider that is a global wrapper to which we pass the wallet we want to use. The modal provider, that is the pop-up you saw before on NeoNova with the wallet we want to use for the connection, and the button we want to use for the connection, so the connection or disconnect button. We have some written here some documentation about the props we can use for configuring the provider, and the possibility to add a URL of your logo to be displayed on the top of the model. Here you have a way to use the New Wallet Adapter library to interact with the wallet, because it is from the React perspective, and here forgive me for if you are an Angular guy or so on, but it's mainly a matter of implementation here. But from a React perspective, here we have, for this library, we have a global wallet provider that is a wrapper of our whole React application that provide the context to it with all the data and methods we can use. And then we have some useful hooks like this one, the use wallet hook that is provided by the package that we can use in order to access some important data from the library. In this case, we get the address of the connected wallet, the Boolean indicating if we are connected, and the invoke function. There are many more that you can access in this hook. And here we are doing an invocation. So we created a really easy component that send a neo to the desired address, and we have here the invoke method that returns a promise. So we wait for its result, and we have all the data needed for the invocation. So script hash operation, as you can see here, is really similar to what you see on the graphical side on NeoNova. So NeoNova is just this transferred to the UI. And is also made for to be easier to be, let's say, used by developers. We have the result that is that contains the transaction ID, and here we just wait for the transaction to be found. So this basically covers the invocation, and here there are some other information about the packages that I already told you before. So this covers the Neo Wallet adapter. This is implemented in the same way. So this is open source and is on our GitHub organization, Rentfuse Labs, and as I said before, can be used by everyone and integrated in your project. Now, to end, let's see. So we saw, to recap, we saw at the beginning who I am, what is, but then we went through NeoNova, how it can be used. Then we go deeper and we saw what is a Neo Wallet adapter and how it is composed. Now we'll go to the last layer, let's say, that is how Neo Wallet adapter is used on NeoNova. So a real implementation of the adapter. So we have it here. We are in the NeoNova package. Also, this one is on GitHub. And our idea was that this could also serve as a reference implementation of the Neo Wallet adapter, production-ready implementation of it. This is a Next.js application. And you can see at first the package.json, the basic package we need. In this case, we are using also undesigned component library, so we have also that one. Then we have the global wrapper, so the underscore app component that is the wrapper of all the pages of the application, on which, as we saw before, which we inject all the wallets we want to be available. And as you can see here, we wrap everything inside. Children will be the pages of the application. Here you can see we have also a local wallet provider, so there is also another step that is done for future implementation on the local net, but is not available as. And then we see, so like we saw before, we provide the context to the whole application through the wallet provider, and then we just use the wallet hook in order to interact with the wallet. So in this case, for example, this is the application button wallet. That is the one you use above in order to connect to a wallet. So in order to show you how easy it is to connect with this using this library, you can see here that we just we are just getting the connected Boolean, the connected flag with the hook, and then above here, we are just using it to show the connect or the disconnect button. And everything is already handled for you. So the modal, the click and connect of the adapter, the disconnect, everything is already used and is already handled for you. This is where you do an invocation. So this was the wallet button you have on the top right on NeoNova. This is the board item. So this is this part of NeoNova. 1 second. The wallet adapter was this one. The board item, the one we are seeing now, is this element. And what we can see here is that at the beginning, in the same way, we have the use wallet hook that here we are using to get more a function, the invoke function, and the address of the connected wallet. And then we have here, you can see here the two kind of invocation. If it's a read invocation, we are not using the wallet because it's a read invocation, as we said before. We are just using the NeonJS library and we do the invocation. We get the results and we set them. If we want to do a write invocation, so an invocation through our wallet, we just do this. So we check that it's connected, that an address, so some basic operation. Then we do our invocation. This is what I told you before that will be changed. We will use, we'll give the user the possibility to set them through NeoNova. In your implementation, you can set that to whatever you prefer. We already support all the witness scopes. And basically, that's it. That's how you, it seems really easy, but it's like this. The goal of this library is to make it easier to interact with the wallet. So in this way, if in the future we'll add a new wallet, like we want to the OneGate wallet, we just add it, or you add it inside the new wallet library. You add your, you don't have to add your package because it will be already there. So you update the wallets package, and you just have to set it here. You will have a new function with the new wallet you want to support, and then you don't have to change anything in your application. Because due to the usage of our of this interface and the fact that each of these wallet adapter inherit from the same abstract class, we use always the same interface to with the wallet. So this covers all of our, let's say, tools that we created. And to conclude, I already stressed enough while doing this presentation, but was to highlight the fact that really our goal is to share things that can be shared, like this one, things that can help others move forward and can help build a successful application on Neo. The more applications there are on Neo, the better for us, the better it is for Neo, for everyone. And we hope that with this library and this tool, we can help you bootstrap your next fantastic application on Neo. So now I'm open to any of your questions if you have any. If you are more shy and want to give us more or information or whatever you want to ask us, feel free to contact us with the email you find here, or join our Discord and write directly on Discord, Twitter, wherever you want. Thank you for your attention.
Thank you very much. That was a tremendous presentation, Michael. Right now, if any of you have questions, please type them into the DevLog channel on the Neo Discord, and I will pass them on to Michael and he will answer them. In the meantime, just to recapitulate, NeoNova is a fantastic tool for you to exercise your smart contracts without having to write a bunch of custom code. Michael did that for you. Or you could test other contracts just to see how they react. And also, the Neon Wallet adapter is a wonderful jumpstart for all of us, so we don't have to figure out the trials and tribulations and the ins and outs of the Wallet Connect protocol, a tremendous protocol that saves you from having to have your users or you pass encrypted private key files back and forth. Instead, they can use Wallet Connect, and from a JavaScript application, they can connect to the wallet and have the wallet take care of the signing of and the preparation of the payload. So again, if you have any questions, please put them into the devlog right now, the devlog channel on Discord. I see some people typing. We have a question from Gwill, and he says, Michael, I would say that NeoNova is the postman of Neo blockchain. Well done. Congratulations.
Thank you. Thank you, Gwill.
And Ioannis, and I hope I said that right, it said, really great job with the presentation, Michael.
Thank you guys for the support.
Claude, and that's from AX Labs, says, hey, Michael, thanks for your work. These are great contributions to the ecosystem. Come on, people, you're making it too easy on them. Let's get some questions in here. Sorry, Michael, I have to do that.
Well, no problem. I'm glad if you have any question. But if you are more shy, it's not a problem. Write us everywhere. Discord, Twitter. We are happy to answer you and to help you.
Maybe you could do me a little favor. I still see some people typing, so I want to give them a chance to get their questions. And can you talk a little bit about Rentfuse, how it works and what it does?
Yeah. So basically, what we are building at the moment, what we are implementing is the front end of Rentfuse, because last week we updated our contracts, our core contract to the testnet, so the one that allows the Rent protocol to fully work. And basically, as I told you before, there are two ways of interacting with Rentfuse and with the Rent protocol. The first one allows you to do a renting operation with collateral. So it will be a way to always enable renting. So to always enable NFT renting with any kind of NFT you want, with any kind of restriction. The only thing that you have to add in this with this method, so the escrow method, is the fact that the lender must decide a collateral. This collateral is needed because it's useful to prevent a borrower to stall the NFT. So what happens is that the lender lists his NFT and he sets a collateral for the NFT. Then when a borrower see an NFT and he say, okay, I want to borrow it, he must send the payment of the whole duration of the renting and the collateral. He then receives the NFT and can use it. Then two things can happen. If the NFT is returned in time from the borrower, then the collateral amount is sent back to the borrower, and the other amount, the payment, is transferred to the lender. Otherwise, what can happen is that if an NFT is not returned in time to the protocol contract, the lender can revoke the renting, and by doing so, it will get all the collateral, because it didn't receive the NFT back. And this is the first method. So the global method that can be used from and with any kind of NFT. The other method that is our what we call the proxy method is NFT safe, because what happens is similar to the other methods. At the beginning, the lender send his NFT to the protocol. The NFT and this method, the proxy method, works only with NFT contracts that adhere to the protocol. So they must follow a procedure that they will be all written on our documentation, but they need to create a proxy version of their NFT contract through our a contract that we have created that automatically create a proxy contract for them. So they create this kind of a proxy contract that is a placeholder of their real NFT contract. And what happens is that when a lender lists his NFT, he lists the NFT, he say, okay, I want to list this, but I want to list it only by using this proxy mode. So I want to be sure that my NFT is safe in the vault. He set this flag. And if the NFT is submitting, if the NFT contract is submitting is an NFT that has a proxy NFT, so if the NFT contract adheres to the protocol, it will say, okay, you can list it. Otherwise, it automatically rejects it in order to avoid setting an NFT that doesn't have a proxy version. But in the case there is this proxy NFT contract pair, what happens is that when the borrower wants to rent the NFT, the proxy version of this NFT is minted directly to the borrower. In this way, the original NFT always stay in the vault, in the rent protocol vault, and the only thing that is moving around is the proxy version of the NFT. The cool thing is that this proxy version is basically the same, is a real NFT, is created through a proxy NFT contract that is NEP 11 compliant. So it's automatically supported by all of the wallets, and it can be used by like a real NFT, like a normal NFT. And additionally, it is called the proxy because it's the calls that are done to it, like the properties call that gives you the properties, like the image, the data, and whatever, is directly returned by doing a call to the original contract. So, for example, if I have a proxy NFT of the NFT number 1, and I call the properties method on the proxy NFT of this proxy NFT number 1, I'll get the properties of the original NFT. It seems cumbersome to explain without diagrams and so on. I hope with the documentation it will be clear, and it's something that at the end is done at the protocol level, so it's a really low-level implementation. And so this was, and the fact is that this implementation is really cool because in this way you are always sure that you can't lose your NFT because it will always stay, the original NFT always stay in the same vault. So this was to give a global overview of the two methods, the core functions of how renting work with Rentfuse. Now I see some questions.
Yeah, we have a question from Ioannis, and he wants to know what kind of collateral will Rentfuse accept? Only gas or BNeo, or can it be outside of the Neo blockchain? Maybe a stablecoin, for example.
Yes, thanks you for your question, Ioannis. The contract is completely configurable, so the accepted collateral and the accepted payment tokens can be set dynamically with the contract. So at the beginning, we to be used for the for the collaterals and the payments, gas and refu token. But it can be further extended to all the other payment tokens. It's just a matter of updating the value in the storage.
All right. Thank you very much. We have a question from Joke. That's his user handle. I'm not saying joke. And he has first a compliment. Thank you so much, Michael, for your presentation. It is a great opportunity to see both NeoNova and a Neon Wallet adapter in action. Now, here's the question. Did you implement Wallet Connect from scratch? I didn't see you import City of Zion's Wallet Connect SDK.
Yeah, so, and it's similar to the question that Will is doing below. At the beginning, I've tried with by implementing myself the Wallet Connect implementation, but I already added an issue inside the Wallet Adapter library with marked as enhancement and help wanted, because after seeing how well is done the Wallet Connect library by City of Zion, they already use that is already working very well with new wallet, is already integrated in Ghost Market, for example. So the next point will be to use that, so to implement that Wallet Connect library below the Wallet adapter, the Wallet Connect adapter. So use that instead of reinventing the wheel.
Thank you. Gwil, I know you answered it, but just to make sure everybody knows what Gwil's exact question was. My follow-up question is, in your point of view, Michael, what are the main differences from City of Zion's Wallet Connect SDK and yours, if any, and what is your main selling point?
For that is as I explained before. So we'll move to the Wallet Connect implementation. So at the moment we have no advantages of that. It was just a starting implementation and to quickly set it up and try it. But seeing that they solved a lot of problems and they make it really great, we will use directly theirs to leverage their work.
Fantastic. And remember, everyone, this is a community built by all of us. Yeah. And we can take Michael's great work and we can add our own solutions, and then all of us can share in the benefits. And that is the important thing to take away from this.
Yes. That is really the most important thing to take away from today, in my opinion. To reuse things that are done by the community, improve things that can be done also for the others, and make great things together.
And let's not forget NeoNova, which is a fantastic tool for exercising smart contracts on the Neo blockchain. I also wanted to ask you, Michael, if you don't mind, what made you decide on the Neo blockchain?
I decided Neo blockchain at the beginning, as you remember maybe, to the Launchpad Hackathon, because I already developed on something on Ethereum, and I already knew Neo, and when I had the opportunity to develop with the hackathon, I saw that it has a really fantastic tooling. It was really easy to develop that. You have also Neo Express that is incredible. The community is wonderful. You always have some helpful answer from the community, and then I didn't have to became better at Solidity or Rust or other languages that I didn't know, but I could have just used a language that I already knew. So there are a lot of languages that you can use: Python, C#, JavaScript. So Java, you can use whatever you want. So I think that this is the most important point. So you don't have to reinvent something. You don't have to learn something new, because you just have to start. So this is basically.
Okay, everybody. I see Claude is typing something. Any other questions? Remember, this is your chance to talk directly to a talented developer in the Neo ecosystem.
Yeah, that's a great. Yeah, Will, that's a great suggestion. I at the beginning, also that thing would be interesting. So Will is saying to create an example GitHub repository with the NWA implementation, like the MIM governance DApp, or directly integrated inside the governance DApp. That could be awesome. I also suggest at the moment when there is not already this implementation to watch directly also NeoNova, because at the end NeoNova is implementing fully the package, but that is a wonderful idea. So also integrating in the governance app. Thank you for the suggestion.
All right. Is there anything else out there? Sam, do you have anything you'd like to say? Well, I guess that wraps it up, everybody. Michael, I really, really appreciate you stopping by and talking about Rentfuse and your wonderful contributions to the Neo ecosystem with NeoNova and the Neon Wallet adapter. Is there anything else you'd like to say before we sign off?
Thank you, everyone, for attending this devlog, and I can't wait to see your application on Neo.
Me too. And everybody, once again, a tremendous thank you for showing up today. My name is Robert Oshler, and this was devlog. Thank you.
Bye-bye, guys.
Bye-bye. Thank you.
Bye-bye.